Right, let's take a look at example 29a. Now, if you look closely at example 29a, right, the question given is in this form. Right, so immediately you know there's a modulus on the left side and then there's a fixed number on the right side. Alright, so this will tell you that we need to draw a circle. Now before we actually draw the circle, we need to write it in the standard form. Now the standard form of the equation of a locus of circle is given by, alright, just to refresh, z minus, alright, p plus iq equals to k. Now remember that z is a variable complex number represented on the Argand diagram by the point p, whereas the p plus iq is a fixed complex number represented by the point A on the Argand diagram. So remember that this is always the distance from the point P to the point A, and this distance happens to be k, which is bigger than 0. Once we have written the equation in the standard form, right, we will immediately know what is the center of the circle and the radius of the circle, and then we can actually draw the locus of this complex number z, as you can see here. One thing to note, okay, alright, you need to label the center of the circle, label also the radius of the circle. Now in this particular example, you notice that the circle actually passes through the origin, and in order for you to actually check this, it is actually quite easy. What you need to do is just find the length hypotenuse, alright, as you can see here, using your Pythagoras theorem. Now in this question we are also required to find the equation of the circle in the Cartesian form. Now let's recap. The equation of a circle in the Cartesian form is given by x minus h squared plus y minus k squared, alright, is equals to r squared. Take note, this k is not the same as this k, alright. Okay, so if I were to write down the general form of the equation of the circle in this form, I will know that the center of this circle has coordinates h and k, and then the radius, alright, is equals to r. So let's see whether we can actually get a similar equation to this. So the way to actually do it is to convert your z into the x plus yi form. Once you have done this, you group all the real parts together, applying the formula for modulus. You will have the square root of x plus 1 squared is equals to root 2, and this can be reduced to right, which shows you the center as negative 1 1, and the radius is equals to root 2, as what we have already established earlier on. Alright, let's take a look at example 29b. Now in example 29b, we are not really sure whether this is a equation that will depict the locus in the form of a circle. Alright, we know that we need to convert, alright, any equations that depict the locus in the form of a circle in this form, in the standard form. Z minus p plus iq, alright, is equals to k. So in order for me to actually convert this particular question, alright, into this particular form, you realize that you actually need to take out this I here. So, and that is actually done in this part. Okay, so simplifying it, you actually will manage to get to this final line, which is exactly the standard form. Alright, and then we already know that this standard form will give you, okay, a center which is 3, -1, and a radius which is 5. Okay, so we are now interested in drawing the circle. Right, so we have the imaginary axis, we have the real axis. Mark out the center at 3, 1. So, sorry, 3, -1. Right, and then you draw the circle which has a radius of 5. So let me just estimate. Right, and then from the center you label the radius as 5. Okay, so what this actually means is that every point on the circumference of this circle actually represents the complex number z. Now it is very important for you to check whether the circumference of the circle passes through the origin or not. Okay, alright, so we are also interested in this question, okay, to find out what is the Cartesian form of the equation of this circle, and check whether our center and radius of the circle are correct. Okay, so as what we have done before, we convert the variable complex number z into the form of x plus yi, and this we can group the real parts together and the imaginary parts together, and then applying the modulus formula, you should be able to get phi squared, and this actually tells us the center of the circle is 3, -1, and the radius is given by the value 5. Alright, let's take a look at example 29c. Now in example 29c, you're given the equation as follows. Right, so again we see that it is not of the form, the standard form, right, because before we actually proceed in drawing the locus of this complex number, we need to write it in the standard form so that it is easier for us to actually draw the locus. Okay, so as we know the standard form, okay, let me write it out again, is of the form z minus p plus iq, alright, is equals to k, and k is bigger than 0. So I need to make the coefficient of z 1. So immediately you realize that you should actually take out the 2. So taking out the 2, you will have z plus 2 plus half I equals to 6. Okay, and then we write it further by simplifying it into the standard form. Alright, so the 2 which is on the left side, you bring over to the right, okay, will give you 3 on the right side of the equation. Alright, so it is obvious from here that the center of the circle is given by -2 minus half from here, and the radius of the circle is given by 3, alright, as you can see in the equation. Okay, so let's start to draw the locus of this equation, complex number. So we have the imaginary axis, the real axis, center at -2, -half, right? So the center is here, -2, -half, right? And the radius of the circle is given by 3. Let me just check. Is this value 3? It can't be. Alright, so it is safe to say that the radius of the circle is much longer than this. Alright, so I will draw the circle with a radius 3. Right, and then you can mark this radius as 3. Now, as you can see that I have drawn the circle using freehand, and the result is not so pleasing. So please make sure that when you present your answers in drawing the locus of the circle, please use a proper compass. Now we are also interested to find out what is the Cartesian form, Cartesian equation of this circle. So as we have seen before, right, you can actually do it on your own and then manage to be able to get the equation of this circle as x plus 2 squared plus y plus half squared equals to 3 squared. Alright, so the Cartesian equation of the circle is given by this. Now, in example 29D, it seems to show you that both sides they are modulus, but be very careful. Please be observant that the right side, alright, which is the modulus of -6 plus 8i, is just a fixed value. Okay, and you know that this fixed value is actually the square root of -6 squared plus 8 squared, right? And on the left you can actually write modulo of z minus the complex number 0 plus 0i, and on the right, evaluating the root, you actually have 10. So in this case, you realize that we are actually drawing a circle with center the origin and a radius of the size of 10. Alright, and this is very simple to draw. Alright, so we have the imaginary, the real axis, center is the origin, radius 10. Alright, so this is the locus of the complex number z, represented, alright, by this equation. So the equation of the circle in the Cartesian form can be obtained easily, alright, as x squared plus y squared is equals to 10 squared, which is 100.